Welcome to This Explainer, where we are going to completely transform the way you approach your Cambridge computer science questions. Think of this as ancient warrior wisdom meeting modern exam strategy. Today, we're focusing on a core topic, image resolution and color depth, but we're not just reading textbook definitions. We're going to learn how to slice through these questions with absolute precision. We're breaking down the exact strategies you need to take isolated facts and turn them into applied, top-tier exam mastery. Because, let's be real, knowing the definition is just the starting line. To really excel, especially in papers with syllabus codes like 0478, 0417, 2210, or 9618, you need to understand exactly how examiners want you to wield that information. You need a strategy, a system, a blueprint, and that is exactly what we are building today.
Here is our roadmap for the session. We'll start with the digital problem hook, define our core concepts, break down the method mark strategy, look at some principal examiner warnings, and finish up with a foolproof 4-prompt memory tool.
Section 1. The digital problem hook. Context is absolutely everything.
Okay, let's dive into this by exploring a massive trap that so many computer science students fall into. Imagine two students taking the exact same exam. We'll call them Alex and Sam. Alex is the overloader. Alex memorizes every single raw computer science fact, every binary conversion, every definition, but provides zero actual analysis. Then you have Sam. Sam rushes. Sam sees a keyword, panics, starts writing immediately and completely misses the command word requirements of the actual question. Both of them lose marks. Why? Because they forget to ask the most foundational question of all. What real-world digital problem does this actually solve? Before you can explain image resolution and color depth to an examiner, you have to understand the practical consequence of these concepts for a user, a system, or an organization. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's get back to it. When you anchor your knowledge to the actual problem being solved, the terminology suddenly becomes a useful tool rather than just a string of words you've memorized in isolation.
Connecting these concepts to reality is absolutely vital because real-world transfer is what the examiners are testing you on. They don't just want you to regurgitate facts. The exact same data representation patterns appear across a massive variety of fields. Think about it. Whether we are talking about the crispness of a display on a brand new smartphone, the load time and file size trade-offs of a media-heavy website, or even the hyper-accurate cameras on a robotics assembly line, image resolution and color depth are at the heart of it all. In secure communication, manipulating file sizes through resolution impacts how quickly and safely encrypted data can be transmitted. In industrial control, a machine vision system needs a specific color depth to detect manufacturing flaws. Anchoring your exam answers to these realistic scenarios helps you remember not only the name of the concept, but the reason for using it and the very real consequences of choosing a high resolution over a low one.
Moving right along to Section 2, defining resolution and depth. This is where we build the foundations.
The crucial point you have to understand here is that image resolution and color depth do not exist in a vacuum. They sit inside a much larger, interconnected chain of ideas within data representation. When you are sitting in that exam hall, you do not reach the highest mark bands by simply writing down short, basic labels like "it makes the picture look better." You have to strike with precision. You are expected to use highly precise terminology, talking about pixels, bits per pixel, metadata, and file size implications. You need to explain the underlying processes clearly and evaluate the digital alternatives. It's about taking your knowledge on a journey, moving from basic recognition to deep contextual understanding, and finally to applied evaluation. That is the examiner's dream.
Now, the danger of memorization without context is immense. We've all been there, staring at flashcards until our eyes glaze over. But the theoretical foundations of image resolution often depend heavily on distinguishing between nearby similar concepts. In computer science, classic exam mistakes frequently arise when learners get their wires crossed. They confuse memory and storage, protocol and service, a compiler and an interpreter, or in our case, they might confuse image resolution with color depth itself. They are related, but they are distinctly different levers you can pull to change a file. Your study strategy must train you to actively compare these nearby concepts side by side. When you practice training by comparison, you build a mental safety net.
You prevent those classic exam mix-ups that cost you easy points. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Section 3, the Method Mark Strategy. Let's talk about scoring with absolute precision.
Now we get into the actual mechanics of exam success. How do we systematically secure marks using a disciplined technical methodology? I want to introduce you to a framework that top students use to structure their computer science answers. It's heavily inspired by the Peel framework: point, evidence, explanation, link. But we've adapted it specifically for Cambridge computer science papers. First, step 1, identify the exact requirement of the task. This is your point. Decode the command word. Are they asking you to describe, explain, or evaluate? Step 2, classify the relevant data, hardware, or process. This is your evidence. Bring in the specific terms like bits per pixel for color depth. Step 3, explain how the process works in a clear logical sequence. This is your explanation. Walk the examiner through it step by step so someone else could easily follow your logic. And finally, step 4, connect the explanation back to the context. This is your link. Tie it right back to the scenario given in the prompt. By following this disciplined 4-step path, you put yourself firmly in the driver's seat. It completely stops you from panicking, brain dumping everything you know about pixels, and hoping the examiner finds something worth a mark.
If you take away only one single thing from this entire explainer, let it be this: specificity is the secret weapon. Generic, copy-pasted textbook responses rarely, if ever, gain full marks. Let's do a quick mental exercise. Imagine a flawed sample paragraph on your screen right now that says, higher color depth means the file size is bigger, which takes longer to download. That sounds correct, right? But it loses marks. Why? Because it completely ignores the scenario. If the exam prompt sets the context in a school database, an office network, or a remote embedded system, your answer must stay strictly inside that context. You need to say, a higher color depth for the school's digital ID photos will increase the overall database file size, requiring more server storage space and potentially slowing down the network when bulk loading student profiles. See the difference? Students so often know the underlying theory perfectly, but they throw away their hard-earned marks because they fail to anchor their explanation to the specific details provided in the prompt.
Let's move to Section 4, Principal Examiner Warnings. These are the classic wrong turns you need to avoid.
It is just as important to know what not to do. Let's bring back our hypothetical student, Sam. Sam's classic wrong turn is vague wording and entirely missing process steps. Students like Sam frequently lose marks by simply naming a device or a method without explaining how it actually works. Or they will state an advantage, like 24-bit color depth is better, but give absolutely no justification as to why it's better in that specific scenario. You need to step onto the correct pathway. This means providing specific context, step-by-step reasoning, and always justifying your advantages. Think like that samurai we talked about earlier. Don't just wildly swing your sword hoping to hit a mark. Slice through the noise with intention. Good study habits mean teaching yourself this correct pathway while simultaneously being hyper-aware of the classic traps. When you read a question, you should instantly recognize the wrong turn that most students will take and actively steer yourself away from it.
To bulletproof your knowledge against these common errors, you need a system. I highly recommend adopting this 3-pass revision cycle. This is your time management matrix for studying. In your first pass, your goal is simply to secure your key definitions and those all-important contrasts we talked about earlier. Get the basics locked in. In the second pass, you elevate. You actively rehearse worked explanations and sketch out diagrams. You practice explaining the difference between 8-bit and 16-bit color depth out loud. And then, in the third pass, you focus entirely on exam adaptability. This is where you challenge yourself, change the scenario, mix up similar terms, force yourself to justify your choices under a time constraint. This layered style of revision is incredibly powerful because modern Cambridge computer science questions almost always combine raw theory with applied on-the-spot reasoning. If you only do the first pass, you are going to get crushed by the application questions.
We've reached Section 5, the 4-prompt memory tool. This is your ultimate exam blueprint.
All right, here is the master framework. Think of this as your cheat sheet recap. If you want to know if you are truly ready for an exam, you need to be able to run any concept through these 4 prompts. Let's use image resolution as our test subject. Prompt 1. What is it? You answer, it's the number of pixels in a given area, usually measured in PPI or DPI, which dictates the detail of an image. Bam! Foundational definition secured. Prompt 2. How does it work?
You answer, the grid of pixels is mapped out, and more pixels crammed into the same space means finer detail but a larger file size. Technical process outlined. Prompt 3. Where is it used? You answer, high resolution is used in print media or medical imaging where detail is critical, while lower resolution is used for web thumbnails to save bandwidth. Context anchored. Prompt 4. Why is it better or worse? You answer, higher resolution is better for quality, but worse for storage capacity and transmission speeds compared to a lower resolution alternative. If you can answer these 4 prompts aloud without checking your notes, your knowledge is officially ready for the exam. If you stumble, you found a gap to fix.
So, you've done the work. You've written your answer and you're staring at your exam paper. Before you move on, run through this pre-submission exam checklist. It's a fantastic habit that will save you so many drop marks. Ask yourself, did I identify the exact command word requirement? Have I clearly classified the data? Is my process sequential? And, crucially, is my answer undeniably anchored to the scenario? If you can check all 4 boxes, your progress bar is at 100%, you are successfully meeting all of the examiner's expectations. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGSC to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGSC and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
I want to leave you with this final, provocative thought to really test your newly acquired exam adaptability. Imagine a severe security incident has just occurred on a school network. You are the investigator. How would you apply the strategies we've discussed today to justify your specific choice of image resolution for capturing and storing the digital evidence? Think carefully about the context, the trade-offs between clarity and file size, and the precise terminology required to lock down those marks. Mastering that level of real-world application is where true exam success lies. Until next time, keep practicing, stay sharp, and ace those exams.